Hello everyone and welcome back. I'm going to continue to do one last regular DC mesh problem. So far I think everyone has a good understanding of how to do this, or I'm assuming you do. However, it can't hurt to have one extra problem. One thing I do want to stress, and I'll give you a sneak peek of the question we're about to do. It doesn't really matter what type of circuit this is, whether it's shaped like a square or a triangle or a circuit, or a circle. It could be any shape, and it really does not matter, especially when it comes to mesh. It's so easy to use mesh on just about any circuit. So I remember when I was taking this course, I would have a question on the test that would throw everyone for a loop because it would be shaped like a cone maybe or something. As long as these wires remain connected in the same type of pattern, they can move any way that they please and mesh should still work. So with that said, let's move on to the actual problem. So first step, move this right out of the way, or actually I'll put it right in behind. The first step should be assign a current to each one of these loops. So we have 3 loops. Everyone should be getting used to this by now. I1, I2, I3. Okay? And the next step is to indicate polarities for each resistor. So this is a step I kind of skipped out on a little bit last problem I did on YouTube. So I hope that everyone understood what I was doing. Now, as you can see, I'm following this current and I'm exiting out of the negative portion of the resistor. Okay? Now I'm following this current, entering the plus, exiting the negative. This looks a little weird, but I think we know what to do with that by now. We come around, we have plus and minus. I say you should know what to do here. You may not have watched the earlier videos, but it'll become quite obvious in a little bit, hopefully. Plus, minus, because we are entering the plus, exiting the negative, entering the plus, out the negative, entering the plus, out the negative. Okay, so let's maybe try to speed things up a little bit while we're writing this. We have, for loop 1, we have 2 volts, we have minus I1 times 1 ohm, okay? Then we go around, we have minus 4 volts, and it's minus because it exits out of the negative, whereas this one exits out of the positive portion of the voltage, okay? We continue down and we have minus I1 times 1 ohm and plus I2, because it's shared, times 1 ohm. Sorry, I forgot the 2 there, equals 0, okay? Loop number 2, we'll start from this area right here. We'll go minus I2 times 1 ohm plus I1 times 1 ohm. And I'm sure many of you guys are speaking this out loud while you're watching this because you're getting a little bit used to me saying this. Positive voltage, because we're going out the positive portion of it. We have minus I2 2 ohms, and come back down, we have minus I2 times 3 ohms plus I3 times 3 ohms. Sorry, it's a little crunch there. Hopefully everyone can see that. 3 ohms, okay? And the last one we have, we'll come down this way, come up, negative I3 times 3 ohms, okay? And it's shared by I2. So plus I2 times 3 ohms. Come back around, we have plus, because we're exiting out of the plus, 2 volts, 2, and minus I3 times 4 ohms equals 0. And that should be equal 0 at the end as well, but we ran out of space. So now we'll put this in matrix form, much like we did in the previous example, if you saw it. So we have negative I1, this is for, we'll do loop 1, loop 2, loop 3, okay? So negative I1 times, we have 1 here, we have a 1 here, so 1 plus 1, 2, I think that's all we have, 2 ohms. Okay, so we got those two. Now we go plus I2 times 1 ohm. I think that's the only one, yeah. And then we have we'll put our voltage over here, leave a space for the I3s when we put them down here, because that actually ends up being 0, no I3s there. So we have 2 volts, which is put on the other side, so it's minus 2 volts, and 4 volts, which we're putting on the other side, plus 4 volts, gives us 2 volts, okay? And we'll do loop number 2 now. We'll start with I1. It's nice to keep I1 in a row together, I2 in a row, and just organize it as much like a matrix as you can. It makes things very easy, and it's nice for checking your answer at the end. We have I1 times 1 ohm, and that's the only one for I1. We have minus I2 times 2 plus 3. So we have 5 and 6. Is that all we have there? Yes. And then plus I3. And I'm sorry if this is starting to get repetitive. There's no way around it. It's just kind of mundane work once you have it figured out. 4 volts, we'll put it on the other side, minus 4. Okay? And then third loop, we have 0 for I1. Let's check I2. We'll go plus I2 times, we have 3 here, that's the only one. And then minus I3 times 3 plus 4. 3 plus, let's just put 7. Okay. Okie dokie. And minus 2 volts. We'll put that on the other side. Okay, so now we have our matrix. Now, when you're doing your matrix, oh my god, I wasn't showing you those. I'm sorry about that. When you have your matrix, you have a great way to check this. And I showed you this in the last video, but you can ignore these. Imagine if these are cut off, and you can put a nice line diagonally right down the middle of that matrix, and you'll notice that these values should mirror each other. We have an 1 ohm and a 1 ohm, okay? We have a 0 here and a 0 here. And we have 3 ohms here and 3 ohms here. And I know this is a little bit messy, and I wish I could have a little bit neater writing to really bring it home. You could even make a matrix like that. But it does show that you can really line this up so that you know that your answer is correct when you finish your problem. Again, I apologize for not moving the sheet up a little bit quicker, and I appreciate everyone watching these videos, and I really hope they do help. If you have any questions or anything that you'd like me to cover, or maybe I'm doing something that you don't really appreciate, just let me know, and hopefully I can accommodate you.